What's up, ladies and gents? Welcome to Maths with Gastin. I am Gastin Mapala. Today, let's have a look at question 2 of November 2021, number patterns, as we continue with this series of hours here at Maths with Gastin. We are dealing with all the question 2s from this past 3 years, 2022, 21, and 2020. So today's question, it's in grade 12. Now let's have a look at this question. Given the geometric series, so yes, the series that is given, it's x. You've got 9 plus 90 plus 81, and then it continues therefore. Okay, so they want us to calculate the value of x. They want us to show that the sum is given by that formula there, and also they want us to also calculate the sum to infinity. Okay, total marks in this question 6 marks, so you should spend more or less 6 marks. Okay, let's go ahead. I'm going to break down this question so that we can have enough space to write here and illustrate what needs to happen. Okay, please make sure that you watch our lesson video, although I think I should do another video when it comes to number patterns, sequence, and series, but it's fine. The information that I've given on that video is good enough for you to be able to tackle any questions or questions like this one as well. Okay, so let's go ahead. 2.1. 2.1 is said we need to calculate the value of x. So how would you go and calculate the value of x given that x is t1, 90 plus 81? Okay, so this is t1, this is t2, and therefore this is t3. Okay, so we know that the value of r, okay, in a geometric sequence is given by t2 all over t1, which should be equals to t3 all over t2. Okay, therefore let's do the substitution here. T2 is 90. Okay, t1 is x, it's unknown. Therefore we also know that t3 is 81, this one we know, and therefore t2 it's given by 90. Okay, so now you can go ahead and cross multiply in order to get the value of x. If we cross multiply, we're going to have x in brackets 81, and we also going to have 90 times 90 should give us 81. Okay, and therefore you're looking for x, therefore you're gonna divide both sides by 81. This 81 cancel out, x should therefore be equal to 100. Okay, great stuff. So we managed to calculate the value of x there. Now let's come to 2.2. Simple, straightforward basics, guys. If you stick to the basics, I can guarantee you could never go wrong, or it will be very difficult for you to make a mistake if you are following the basics. Okay, all right, so now they're asking us here to show that the sum of the first n terms, it can be given by this formula here. All right, so basically they're just asking us to show that the general formula for the sum of this series is given by that. Okay, so what do we need to do this? We need to know which formula to use. There's 3 formulas there in your formula sheet, guys. So you go there and have a look and say, okay, no, the formula that I'm going to use, whichever one I'm going to use, I need to make a decision based on r. Okay, so let's look for r first. We did say that r is going to be given by t2 over t1. So what is t2 here? T2 is 90 all over t1, which is 100, is going to give us a 0.9. So therefore our t here, or rather our r, you can go ahead, guys, and prove that t3 will be also equal to r will also be t3 over t2, which I have checked before when I was preparing for this lesson. So therefore you can just prove it, guys, to also check your answer that you are correct. Okay, I'm just going to put it here that you can also check if r is correct by saying t3 divided by t2. Also, this will also assist you to check that you also got t1 correct at 2.1. Okay, all right, so therefore now we know that, so our r is less than 1, that everybody can see that we agree it's less than 1. But however, even though it's less than 1, it is again greater than -1. So therefore according to the formula, all right, and also the lessons. The formula that we must use is Sn is equal to A1 minus R to the power of n, close bracket, all over 1 minus R. Okay, so we're looking for nth term. We know what is A. A is the first term, so our first term is what? Our first term in this case is x, which is 100. 100 close 1 minus R is 0.9 to the power of n. Okay, power of n, close bracket, therefore all over 1 minus R, which is equal to 0.9. Therefore Sn is going to be given by, if you were to simplify this, you should be able to get 1 minus 0.9, and close bracket, here at the bottom you should be having 0.1, which if you 100 divided by 0.1, therefore this n should be able to give you 1000 in bracket 1 minus 0.9 in bracket to the power of n, which is what is required. Therefore you should be able to get 2 marks there as well. All right, okay, so now we have got that out of the way. Let's go to 2.3. Okay, 2.3 says, hence otherwise calculate the sum to infinity. All right, okay, so what we need to do here now, what is the formula to sum to infinity? Sum to infinity, first let's see if we've got everything that we need, is given by our a1 all over 1 minus r. Okay, let me check on the formula sheet. This should be correct. Okay, no, it is correct, right? Okay, so can you use this formula? Yes, you can use it, guys. You can use the formula of sum to infinity if r is less than 1 but greater than -1, which in this case it's what the equation is given us. So a, we have calculated a previously at the back there. We know that a is equals to 100 all over 1 minus r, which is equal to 0.9. Therefore this should be giving us that sum to infinity is equals to 1000. All right, okay guys, and that's how you would deal with this question of November 2021 question 2. So guys, please make sure that you stay tuned and you subscribe to Maths with Gaston. See you on the next upload where we will be doing question 2 November 2022.